In this video, I'm going to show you how to do the simulation for an RC and CR circuit. One of them is a low pass filter and the other is a high pass filter. So let's first go and select components. So you go to basic for the resistor and get a 2K resistor. I'm using a virtual machine, so it's a bit slow. 2K. And then I want a capacitor, which is 0.47 micro. And I want a power source. So you go to sources and wait for it. Power sources and AC power. Okay, what's missing is the ground. So select ground. Right. Now I have everything I need to start connecting the circuit. Let me zoom in a bit. Okay, so I want 5 volts, so I'm just going to double click and change this to 5. Hit OK. And then connect the components. First, I need to flip this and connect them. Okay, so click here, drag and click. Then finally, the ground. I'm going to name this so I can select it later. You'll see how I will need it. Properties. And then preferred net name is RC. And then show net name. Okay. As you can see now, we named this wire. We will need this name when we are selecting where do we want to see the AC analysis. Okay. So now you go to simulate and then analysis and simulation. And then AC sweep. And I want to show you something. So I'm just going to take a small portion of the signal or of the response, frequency response. Decade, let's choose 4 points and decibel. Now you have to go to output. And remember, we named this voltage right here, or this wire right here, RC. So add it. And then you need to look for run. Okay, so I had to make the screen thingy shorter so I can see the run and then run. Okay, so I just did now plotted the frequency response of the filter for frequencies from 1 to 100. Let me show you how many points we used. We selected 4 points per decade. Okay, and a decade is from, or if I had a frequency f, a decade would be f times 10f. So from f to 10f, that's a decade. Okay. And here from 1 to 10, it's a decade. And how many points are there? 1, 2, 3, and 4. This is with the other decade. Now, let's look at what if we increase the number of points for 0, 1 and run. So now, as you can see, all of the selections we made earlier are still there. So I'm just going to change the number of points per decade to 401 and then run. Double click to rename. You don't need to rename, or just for convenience. 401. Okay. Now for the 401, let me change the view to points. Look, there's no more guessing. All of the points here are evaluated. Here, the values in between are estimated by the software to draw the line. Okay, so it's always better to choose more points. Now let me plot the full frequency response of the filter. So I'm going to go to simulate, analysis and simulation, and I'm going to increase the range to 100K and run. I have this longer range, as you can see. Let's choose the line view. This is the response of this filter. Now, how can I find FC, or how can I look at FC from the graph? So you know from theory you can find FC at -3 dB. So you can either drag any of the cursors. I clicked here to show cursors, and then I can drag any of the cursors, and for example here I chose cursor 2, so I'm going to look at x2 and y2. Okay, I am looking for y2 to be -3. Okay, so now it's -3.2. I want it to be more accurate. 2 point. Okay, let's see if I can find a better one. All right, this is better. So this is almost -3 dB, and I am getting here at x2 the value of FC. Now this is the value in the simulation. What is the actual value, theoretical value? I can find the theoretical value by doing this, 1/2 pi, and then the resistor was 2K, 2E3, times the capacitor was 0.47 e to the power -6 micro. So the theoretical FC cutoff frequency is 169.31. And what did I get? I got 167.79. Okay, maybe if I use more point I'll get a more accurate reading. Now let's see the response of the other filter, which is the CR filter. I'm going to change a few things. Control X, Control V, then Control X, Control V. Now let's flip it back. Now we're doing a CR circuit. Flip, reconnect, reconnect, and reconnect. Now let's name this wire here. Right click, properties, and let's name it CR, show net name. Okay. Now we're going to do the same thing. Let me zoom out a bit. Okay, simulate, analysis and simulation, AC sweep from 1 to 100K, decade for 1 point decibel. Okay, and then here we select this voltage of CR. Okay, now let's run. Right, so I can see that this is a high pass filter. And where can I find the cutoff frequency? Again, I find it at -3 dB. I'm gonna look here. There's an alternative way of doing this, which is clicking on the cursor and then set Y value -3. And in this case, it got me exactly the -3 point, which is 169.7, which is closer than the previous value. So you can either do this, clicking on the cursor and then right click and then set Y value to the value that you are looking for on the Y axis, and then you can go here and read what is the x value, which is going to be on here, on the x-axis, which is frequency. Or you can drag the cursor around. Sometimes dragging it around you cannot find the right value. Sometimes using the set y value doesn't work properly. So you check both cases and you choose what is more convenient for you and accurate.